Hi there. For this video, we'll be solving rational equations by using our first method, which is called the cross multiplication method. So basically, what we'll do is, if we have a over b and this one is equal to c over d, what we can do is we can multiply this two and multiply this two. So we'll have AD on the left side and BC on the right side. So basically, we'll convert a rational equation into probably a linear or a polynomial equation in general. So note that this works because we can, since we have an equation, we can multiply something on the left and we'll definitely multiply that as well on the right. So observe that when we multiply both sides of the equation by the denominators, by b and d, this one out here will cancel out and this one out here will cancel out, giving us the AD equals BC, or the cross multiplication wall. Let's have this first example. Let's have x minus 1 over 2 equals 3 over 4. There. Okay, to solve this one, the first step before we even go to the cross multiplication process is we first check its domain, since we're dealing with rational equations. Now first, note that are there any values of x that would make this rational expressions on the left and in the right undefined? Or by that I mean, is there a value of x that would make the denominator be 0? Clearly, none, since our denominators are already fixed. The denominator on the left side is 2 and the denominator on the right side is 4. So nothing will really change by changing the value of x. So we say that the domain for this one is all real numbers. So upon solving this, whatever value of x that we get, as long as it's a real number, we consider it as a solution. So solving for this one, going to the cross multiplication method, we obtain 4 times x minus 1 equals 3 times 2. Simplifying, we distribute the 4 out here to obtain 4x minus 4 equals 3 times 2 is 6. We move this negative 4 to the right side to obtain 4x equals 4 plus 6 is 10. Lastly, we divide 4 both sides to obtain x equals 10 over 4 or 5 over 2. And this one out here is the answer for this rational equation. Next, we have 2x minus 5 all over x plus 5 equals 3 over 4. again, the first thing that we will do is we'll determine the domain of this rational equation. First, in this denominator, when will this denominator be equal to 0? It will be equal to 0 if x is negative 5. Indeed, if we have negative 5 plus 5, that is 0. So we know that negative 5 cannot be part of our solution set. For the right side, since this is a fixed value, we can't, or nothing really changes with it when we change the value of x. So by that, we say that the domain for this one is all real numbers minus the negative 5. So when we obtain x equals negative 5 upon solving this rational equation, we can't consider that as a root or as a answer for this one. So applying the cross multiplication process, we'll obtain 4 times 2x minus 5 equals 3 times x plus 5. Simplifying this, we'll have, on the left side, we'll have 8x minus 20 equals, the right side will have 3x plus 15. Next, we move this 3x to the left side, and we move this negative 20 to the right side. To obtain 8x minus 3x is 5x, and on the right side we'll have 20 plus 15 or 35. Lastly, we divide 5 both sides. This will give us x equals 35 over 5 is 7. And this one out here is the answer for this rational equation. 7 can be considered as our answer since 7 is part of our domain. Let's have this one final example. Let's have 3 over y plus 2 equals y minus 3 all over 2y plus 4. Again, we first determine the domain for this one. For this denominator, this will be equal to 0 if y is equal to negative 2. Since if we have negative 2 plus 2, that is 0. So we take note of negative 2. For this one out here, when will this be equal to 0? Well, note that we can write this one as 2 times y plus 2 by factoring out the common factor of 2. And we also have y plus 2 out here, so we know that this expression will be equal to 0 if y is equal to negative 2. So with that, we determine that the domain for this rational equation is all real numbers except negative 2. So we can now start solving this one. So upon cross multiplication, we'll have here 3 times 2y plus 4 equals y plus 2 times y minus 3. So on the left side, what we'll have is we'll distribute this 3 to the 2 terms to obtain 3 times 2y is 6y and 3 times 4 is 12. And on the right side, we'll have y plus 2 times y minus 3 by FOIL. So let's write that out here. By FOIL method, we'll have first y squared, the outer terms, negative 3y, the inner terms, plus 2y, and the last terms, which is negative 6. So simplifying the right side, we'll have 6y plus 12 out here, and on the right side, we'll have y squared minus y minus 6. Now from here, let's combine the like terms. So let's try to move these two terms to the right to obtain y squared. 0 equals y squared minus y minus 6y minus 6 minus 12. This simplifies to 0 equals y squared minus 7y minus 8. So let's clear out some space out here. To avoid confusion, since this is an equation, we can actually flip this up. So we can move this one out here. And we'll have this one. So maybe now it's much clearer that what we have is a quadratic equation. So by factoring, the right combination is y minus 9 and y plus 2. Indeed, if we multiply this, we'll obtain this one. And when we add this, we'll obtain this one, the negative 7. So if you're not sure with that, you can check out my factoring quadratic trinomials video or my factoring quadratic equations to test your skills on this one. And from here, we can conclude that for this equation to hold, either this is equal to 0 or this is equal to 0. So we'll have y minus 9 equals to 0 or y plus 2 equal to 0. Simplifying these, we'll move this one out here and this one out here to obtain y equals 9 or y equals negative 2. So we have y equals 9 and y equals negative 2. Is this the final answer? Take note that we go back to our domain. Observe that in our domain, we can't have negative 2 in our answer, since we know that negative 2 would make the rational equation out here be undefined, since the denominators will be 0. So y equals negative 2 out here is not part of our solution. We call it extraneous in this case. And so our only answer for this one is y equals 9. And that is the importance of the domain in solving rational equations. It's useful to cross out the solutions that is not really part or is not supposed to be part of our final answer. To end this, here is an exercise that you can work on. We have b plus 6 over b minus 5 equals b plus 4 over b minus 9. Again, the first step is to determine the domain before applying the cross multiplication. Also, note that the cross multiplication method is only really useful if we have like single expression like this one and single expression like this one on the left and the right side. If we have, say, a over b plus c over d equals ABCD e over f. That's it. Now this one, it's not really easy to apply the cross multiplication immediately if we have two rational expressions out here, or two rational terms. So we'll dive into more methods in the next videos for you to be able to choose which one you like in solving rational equations. But cross multiplication is a good start since it's very easy to use and it's very straightforward. Just don't forget the domain checking. So that's it. I hope you enjoyed this video. Feel free to comment down below your solutions and your answers and even questions to this exercise and this topic in general. So that's it, and that's all for this video.